Hello students and welcome to very first lecture of chemistry class. But before we begin, let me introduce myself. My name is Vijay K. Bhattacharjee and I have done my mechanical engineering from Guwahati University, and by profession I am an application design engineer with 3 plus years of industrial experience and 2 plus years of teaching experience. So let's begin our class. So first, why you need to study the solid state? As because we see around us many things like oceans, mountains, houses, buildings, etc. And we can see that maximum of the things are solid in nature. So in periodic table also we can see that maximum number of elements are solids in nature. So it is very important to study the solids and their properties. These solids have different properties and depends upon the nature of constituent particle and binding forces operating between them. The correlation between this structure and properties helps the discovery of new materials with desired properties. So what we will discuss in this chapter? We will discuss the different possible arrangements of particles resulting in several different type of structures, and why those different arrangements of structural lend to the different properties of solid, and at last how these properties get modified by adding some impurities in them. We all know that matter can exist mainly in three states: solid, liquid, and gases. There are two opposing factors in which this solid, liquid, and gas depends. We can determine whether the particle is solid, liquid, or gas. It depends on the two factors. Number one is the intermolecular forces, and number two is the thermal energy. We can see it in the animation that the molecules are vibrating at a speed, and when we increase the temperature of that molecule, the molecules start moving far from that other molecule. And if we further increase the temperature, the molecules are now at a very far distance from other molecules. Similarly, if we increase the intermolecular force between those molecules, then we see that the molecules are coming close by it. And if we further increase the intermolecular force, then we can see that the molecules are very much now closer and formed a rigid structure. Now we will see that what are the characteristics properties of solid state. Number one is they have definite mass, volume, and shape. We can see it in the structure that it has a fixed height, length, and breadth. So solid has a definite mass, volume, and shape. Number two, the intermolecular distance are very short. We can see that the molecules are very close to the other molecule. Number three, the intermolecular forces are very strong. In solids, the intermolecular forces are very strong enough to hold together very tightly. And number four, the constituent particles have fixed position and it can oscillate only about their mean position. We can see that in the animation that the particles are oscillating about their mean position, and at last they are incompressible and very much rigid. As the molecules are very close and the intermolecular forces are very strong enough, therefore it becomes very much rigid and very much and incompressible in nature. Now we will study about amorphous and crystalline solid. So solid can be classified as crystalline or amorphous on the basis of nature of order present in the arrangement of their constituent particles. Examples of crystalline are sodium chloride and quartz, and examples of amorphous are glass, rubber, etc. Crystalline solids have very long range order, which means that there is a regular pattern of arrangement of particles which repeats itself periodically over the entire crystal. For example, sodium chloride and quartz. On the other hand, the amorphous solid have very short range order, In such arrangement, a regular and periodically repeating pattern is observed over very short distances only. Crystalline solids have a very sharp melting point. At a characteristic temperature, they melt abruptly and become liquid. On the other hand, amorphous solids have varying melting temperature. Crystalline solids are anisotropic in nature. That is, some of the physical properties like electrical resistance or refractive index show different values when measured along the different directions in the same crystal. On the other hand, amorphous solids are isotropic in nature. That is, the properties such as mechanical strength, refractive index, and electrical conductivity are same in all directions. It is because there is no long range order in them, and arrangement of particles is not defined along the directions. Hence, the overall arrangement becomes equivalent in. So that's all for today. We will continue in the next class. To get the notes of this lesson, please register yourself and you will get your notes and assignments in your email. Thank you.